big rule on square root, on radicals, bottom line is you never, ever, ever, ever leave a radical, and I'm going to say it more generic like that, square root, cube root, the symbol, the radical in a denominator. Now, where's the denominator in a fraction? Uh-oh, better know that. Where's the denominator? What's the top called? It's on the bottom. Numerator over denominator, on the bottom. And if you have one, you got to get rid of it somehow. Probably the hardest part is figuring out where to start. So I'm going to say to you, the best thing you want to do is see what you can simplify and see what you can reduce. And I know you would rather me call it cancel. And it's kind of got multiple things you can do. It says division, but we're actually doing it as fractions, you know, like a top and bottom. So it is division. Fractions mean division, you know. 12 over 4 equals 3 because 12 divided by 4 is 3. So let's start out with a fairly simple one. Let's do 3 square root of 6 over the square root of 25. Now let me talk about what these words mean. Simplify means you have a square root of 20 and you can break it down, like your quiz today. That's what I'm calling simplify. You know, a lot of times we call simplify, reduce the same thing. But reducing, I'm literally talking about, you know, dividing by 2 over 2 or whatever. Now, you can only cancel just like we could only multiply. Let's see, do we have that lesson? Surely we had that lesson. Yeah, you multiply the outside and you multiply the inside. You can only divide the outside, divide the inside. Let's see, let's say cancel inside, cancel outside. Okay, and the first thing I would do, well, what would be the first thing you would do? The only thing I see is that thing right there. Do we know that? What is that? 5. So I'm going to put 3 square root of 6 over 5. That is now an outside. See, it's a rational. This is our rational. In Algebra 2, we call this rational, this irrational. You can only cancel rationals. You can only cancel irrational. So in this case, the 5's on the bottom. There's no radical in the denominator, and we're through with it. That's a fairly simple one. That's where I call it simplify because you break it down. Number 2. Let's do 3 square root of 2 over 6 square root of 32. Now, I cannot simplify. Remember, I'm using that term, simplify, like your quiz today. I can't break down the square root of 2. I could break down the square root of 32, and that's where I'm going to actually work it both ways for you. I'm going to show you which way you prefer. I actually prefer this first. I like this canceling inside-outside thing because I think it makes it a little bit easier most of the time. That's where it's hard. You know, you like concrete rules. You like Ms. Brown to say, this is the way you do it, and that's it. But these kind of have some options. Can we cancel outside? Can we? Can we cancel those? Yeah. 3 goes into 3 one time. 3 goes into 6 2 times. Now, what about these inside? Can we cancel 2 and 32? 2 goes into 2 one time, and that's still under the square root. You got to pay attention. And 32, 2 goes into 32 how many times? 16, and that's still under there. Now, it's kind of sloppy looking, so let's write what we have. We have 1 square root of 1 over 2 square root of 16. Now, I don't have any more canceling. 1 over 2 won't cancel. 1/16. We've already done what we can to. Now, what can we do to clean this up? Do we know the square root of 1? 1, isn't it? Is square root of 1 1? So you got 1 times 1 on top. Just pacify me and copy all the steps. That's what helps you with your notes for your classwork. And then what about the bottom? I've got a 2. Let me put a dot there so it looks more like multiplication. Do I know that? Yeah, what's the square root of 16? 4. So on top I have a 1, and on the bottom I have an 8. And the goal was to get rid of the square root. I can have square roots on the top. I cannot have square roots on the bottom. I don't know who mathematician said that, but that's the way we said it. You know, it's like one of those rules you kind of wish they hadn't made up, but that's the way it's simplified, set up. Oh, and then I was going to put or. I'm going to work it another way just to show you that you got options. Oop, if I copy it down right, square root of 32. Okay. 3 square root of 2, and I'm giving you options. I like the top one better. I just think it's quicker, and people forget about that. They tend to want to do it like this because that's what you did on quiz. We've got 3 square root of 2. I can't do anything else to that. But the factor tree of 32 is a bunch of 2's. I think it's all 2's. 16, 2, I think it's 5 of them. 8, 2, 4, 2, 2. So I've got a pair of 2's, a pair of 2's, and a 2. So I end up with, now, hopefully, you had your quiz today, so I think you can handle this, what I'm fixing to do. I've got a 6 on the outside. Everybody watching? Now, instead of putting the square root of the 2 squared, I'll tell you, I'll write it under here, 2 squared, 2, then I'm going to shortcut it, and I'm going to go ahead and take the square root of that one, which would come out, take the square root of that one, which would come out, and leave that one inside. So I have 3 square root of 2 over, what is that, 24 square root of 2? Now, what cancels? The square root of 2's are gone. That's square root of 1 over square root of 1. They're gone. And what about the 3 over 24? Will it reduce? Yeah, look, it becomes 1/8. Now, I think this was the easiest one. If I can keep from doing factor trees, I think it's easier and faster. If you can do it. That's where you get into trouble, because sometimes you can't do it. Let's try another one. Let's do 5 square root of 6 over the square root of 3. Now, I don't have this as an option in this one because square root of 6, 2 times 3. It won't break down. 3 won't break down. What's the number in front of that square root? What's the rational number in front of that? A 1. Okay, and remember, we can't, that's not simplified because you can't have the square root of 3 on the bottom. That's what you got to get rid of. So 5 over 1 is just 5. And what about the square root of 6 and the square root of 3? 3 goes into 6 2 times. 3 goes into 3 1 time. Now, I'm putting that step in there. A lot of you would skip the next step, but I'm going to put it in my notes so that you know where. I'm going to put the 1 there, and I'm going to put the square root of 1 there, because people struggle with what's left. And so on top, I have 5 times square root of 2. On the bottom, I have 1 times 1, which is 1, and that's just 5 square root of 2. Now, if you leave this, I'm fine with it. If you leave that, obviously, but if you leave this, I'm going to put NS for not simplified. That's what that means. If you got an NS, I write a lot of NS's on these lessons because you'll leave the square root of 20 or you'll leave the square root of 50 or something and you didn't break it down. So that's what I mean when I put NS there. Don't leave square root of 1s, don't leave something you can break down, and don't have square roots on the bottom. Now, what are we going to do? This is going to be our split. Okay, number 4. We're going to actually set it up, and then we're going to talk about the rule underneath it. 6 over the square root of 3. Okay, breaking down. I got a 6, and in this I've got a 1, remember? I got 6 and 1. I mean, there's still going to be 6 and 1. I don't have a, I mean, technically I have a square root of 1, but that's not going to, I can't do anything up here. I can't break anything down, simplify. I can't cancel anything, outside, inside, so I'm stuck. But I got a square root of 3 I got to get rid of. Do you remember in elementary school when teachers taught you how to get equivalent fractions? Like, and I think y'all probably learned it by pizza or something like that. You know, they take the pizza and cut it into 8 slices, and they would give you 4. Okay? But then they just take the pizza and only cut it into 2 big slices, and they'd give you 1. But you had the same quantity, you had the same amount of pizza, you just had a different number of slices. 4/8 was the same thing as 1/2, which was the same thing as 10 over 20, if you cut it into 20 pieces, which was the same as 4 over 8, I may have already said that one, 3 over 6, whatever you cut it into. Well, the way you do that is based on the idea of multiplying by 1. We're trying to get rid of that square root of 3 on the bottom, and I'm going to multiply by square root of 3 over square root of 3. Now, did I just randomly pick that number? No. let's see what's going to happen. Oh, on top, I have 6 on the outside. That's a rational number. And if you want to put 1 square root of 3 here, you can. So I've got 6 square root of 3. We're good with that. Now, what do I have on the bottom? 1 times 1 on the outside. And square root of 3 times square root of 3, which is square root of what? 9. And if you remember, when you multiply a number by itself, you're going to actually get the square root of 3 times square root of 3 is actually going to be 3. You don't even have to go through that step if you want to. So you get 6 square root of 3 over, can I go ahead and put 3 there? Okay. It's right. It's now, the radical is gone. The square root is gone, but I can do another canceling. Do you see another canceling? Now, why can I not cancel those two? You see why? One of them's inside, one of them's outside. That's irrational, that's rational. Can I cancel these two? Yes. So if you leave it like this, it's not wrong, it's just not finished. So it's 2 square root of 3 over 1, or just 2 square root of 3. This is called rationalize the denominator. Now think about what we're saying. You keep hearing me say that word rationalize. Rational. I talk about rational numbers. Rational numbers are numbered, they can't be the square roots. So we're trying to take this denominator and make it a rational number, which is a 1, a 3. It's becoming only a number that's on the outside, not a number on the inside. And how do you do that? You multiply by the radical in the denominator. And so that definition is going to work for cube root, fifth root, whatever that you get down the road, even though we do them a little bit different. And I'm going to say in the denominator, just the one in the denominator, in the form of 1. Now, here's the deal. You don't want to jump to this first. And I'll put an arrow back up here. That's what we just did in number 4. I only do this as a last resort. When I've done everything I can do to it, if you'll let me go down just a little bit, we never even talked about this up here in 1, 2, and 3. If you can break something down, square root of 25, square root of 32, if you want to, different ways, you can cancel. If you can do anything to it first, only do this if you absolutely have to. Let's try one.